is the age of the universe? It's challenging to grasp that a mere 90 years ago, we were unaware of the majority of the universe's existence. At that time, astronomers generally believed that the Milky Way encompassed all the stars in the cosmos. In 1917, Heberdas Curtis observed a nova, a sudden and bright burst resembling a new star within what was then called the Andromeda Nebula. Typically, novas appeared rapidly and then slowly faded over weeks or months. Curtis's interest was piqued, leading him to search for additional novas in photographic records. He identified 11 more novas, but what intrigued him even more was the observation that novas in Andromeda were considerably dimmer than those in the Milky Way. Utilizing this discrepancy, Curtis made an estimate that Andromeda was situated 500,000 light-years away. Consequently, he became an advocate of the island universe hypothesis, asserting that entities once thought to be spiral nebulae within the Milky Way were in fact distinct galaxies. This was a revolutionary step for mankind in cosmology, but we still assumed that the universe was static. Albert Einstein even added something called a cosmological constant to his equations to make sure the universe stayed still. Cut to 1928, and Edwin Hubble's measurements of galaxies led him to the realization that the universe was uniformly expanding. This observation implied that the universe possessed a finite age, and this age could be estimated by mathematically going back in time. With this, Edwin Hubble first estimated the universe to be only 2 billion years old, which now we know is way off than the universe's actual age. The discovery of cosmic microwave background radiation, announced in 1965, finally brought an effective end to the remaining scientific uncertainty over the expanding universe. While we were now sure that the universe was expanding, to the remaining scientific uncertainty over the expanding universe. While we were now sure that the universe was expanding, its true expansion rate continued to be a mystery over the next few decades. Uncertainties surrounding the actual expansion rate sparked a vigorous debate, with estimates ranging from 8 billion to 18 billion years.
The dent in the calculation showed up more pronounced when scientists began to calculate the ages of the oldest main sequence stars, and found that there are more than 8 billion years old. Logically, there cannot be stars older than the universe itself, and this brought us to a dead end in cosmology. And came the Hubble Space Telescope, and in 1997, its observations triumphantly broke that dead end by announcing that the universe was not expanding at a constant rate, but accelerating due to an unknown repulsive force termed as dark energy. When dark energy is factored into the universe's expansion history, astronomers arrive at an age for the universe of 13.8 billion years. However, a significant challenge arises in the field of cosmology regarding a crucial parameter used to characterize the universe's expansion rate, the Hubble constant. Despite expectations based on fundamental physics and cosmic background radiation suggesting a value of around 68 kilometers per second per megaparsec, this conflicts with observations of stars and galaxies in our immediate vicinity. This inconsistency prompts the question, what if our understanding of the universe's age is only a partial truth? A particular group of stars within the Milky Way seems to be as old as, if not older, than the universe itself. Star cluster M92, a densely packed congregation of stars located roughly 27,000 light-years from Earth, is now estimated to be around 13.8 billion years old, aligning its age with that of the universe. This could break the current age of the universe and put a new limit on it, thereby helping solve cosmic conundrums about how the universe evolved. The age is on the edge, as estimated by other groups, said astronomer Martin Ying of Dartmouth College. It helps us set the lower bound of the age of the universe. We don't expect the star cluster to be born before the universe, right? Globular clusters such as M92 consist of densely packed groups of stars believed to have formed simultaneously, simplifying the task of determining their ages for astronomers. Stars follow different life paths depending on their mass at birth. Larger stars burn through their fuel quickly and have shorter lifespans, while smaller stars endure for longer periods. understanding how many stars in a cluster have transitioned beyond their primary fuel-burning phase provides insights into when the entire cluster originated. However, age estimations traditionally rely on assumptions about stellar evolution. Seeking a more reliable method, Ying and colleagues employed a computer to generate 20,000 synthetic stellar populations for M92, each representing a potential cluster age. They then compared the colors and brightness of each population with observations from the Hubble Space Telescope, determining the age that most closely matched the collected data. While M92's age has been measured before, previous estimates depended on a single synthetic star collection. By comparing thousands of synthetic populations, the researchers significantly reduced the uncertainty associated with assumptions inherent in each model. This novel technique resulted in a 50% reduction in the uncertainty of the cluster's age.
The team determined that M92 is approximately 13.8 billion years old, with a margin of error of around 750 million years. Remarkably, this age aligns closely with the best estimate for the age of the universe, slightly over 13.8 billion years, with an error margin of approximately 24 million years. One way around that tension is to accept a different age for the universe, so cosmologist and study co-author Mike Boylan, Kulchin of the University of Texas at Austin. If one takes the Hubble tension seriously, then one also has to say we don't know the age of the universe that well, he added. This discovery puts the lights back on the recently published University of Ottawa study that claims the universe is not 13.8 billion years old, but 26.7 billion years old. To basically sum it up, the new model stresses the existence of stars like Methuselah, which appear older than the universe's estimated age, and the discovery of early galaxies with the James Webb Space Telescope. These early galaxies, observed only 300 million years after the Big Bang, exhibit levels of maturity and mass typically associated with billions of years of cosmic evolution, presenting a significant puzzle. But advancements in computing, theoretical understanding, precise measurements of cluster distances such as M92, and finding primordial galaxies at the dark ages justify a renewed approach. What do you guys have to say? Is the universe older than 13.8 billion years? Do we need a new approach? Renowned physicist Michio Kaku had in fact called it a year ago.
Hey, Professor, I'm thinking of some of my favorites, the God equation, physics of the future, future of humanity. Most of them say the universe is about 13 billion years old. What if it's not?
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only half a billion years old. Something is wrong. We may have to revise our theory of the creation of the universe.